I've got a deck of cards here. What is the probability that I get a black card from a deck of cards? Deck of playing cards. Not a trick question. The probability of getting a black card with how many black cards are in the deck? 26. So half the cards are red and half the cards are black. So the probability of getting a black card is 1/2. Good. So I'll write that up on the board. We'll say 0.5. Oftentimes we'll write this as P equals 0.5. I went ahead and write the sentence up just so we can kind of refer to it and remember what that P equals 0.5 actually means. So if I dealt you 10 cards, how many of these would you expect to be black? 5. Now, are we always going to get 5 cards? No. Why not? Say it again. Why will I not always get 5 cards if I select 10? What have we studied recently about that? Yeah, so random sampling variability, right? Different samples will give slightly different results. Okay, so I'm going to have you guys pick a card. And we're going to look for a black card. And for everyone who selects a black card, I'm going to give you a chocolate chip cookie. So let's go ahead and open these up. Ooh. Okay. So go ahead and start with Yvonne. Pick a black card. So what we get? We got a 9 of diamonds. Okay, so we're gonna put this back in the deck with replacement. We'll let Kwaku do one. What do we get? Red card. In fact, let's go ahead and have a scorekeeper. Kwaku, would you mind going to the board and keeping score? So we'll have black and red. And so far we have 2 red. Okay. We'll do a couple from each group. What do we get? Ace of hearts, ace of red, ace of hearts. So let's see what we got here. Here we go. What do we get? A 10 of hearts. Okay, so no cookie for you. So that's how many?
I get to draw one.
Red. Okay, that's right. Everyone wants a chance at a cookie. Don't be peeking now. And we got a 6 of diamonds. So 5 red. Everyone wants a chance at a cookie, so we'll see what we can do here. King of hearts. So it's also a red. So another red. Six of diamonds. So another red one. Let me know when we get to maybe 10 or so. Ace of hearts. Another red card. We don't like this game. Okay, either one. Okay, your turn. Want that chocolate chip cookie, don't we? 7 of hearts. Okay. 8 of hearts. 8 of hearts. So how many do we have there so far? We have another red card. We got it? King of diamonds. And all this is on video too. You guys are messing up my activity. Let's go and talk about this a little bit. We've done this about 10 times now. Do we still think the probability of getting a black card is 50% from this deck? No. So is it possible? You can sit down, Kwaku. Is it possible that we could get 10 red cards in a row? Is that possible? It's possible that we get 10 red cards in a row, but is it likely that we get 10 cards in a row given that the probability of a black card is 0.5? Is that likely? That's very unlikely, right? So we have something very unusual or surprising that just happened, right? We have a hypothesis that states that the probability of a black card is 0.5, yet we just did an experiment where we got 10 red cards in a row. something seems inconsistent. That is, if this were true, the probability of a black card being 0.5, it would be highly unlikely that we actually get 10 red cards in a row. Yet we did get 10 red cards in a row. So what can we conclude about our hypothesis? What can we conclude about this, Kweku? About the probability of it being black, being 1/2. Is this true? We're probably going to reject this and probably say it's probably not 0.5, right? Think about what we just did. We set up a hypothesis. We assumed it was true. We then collected data that was sort of relevant to that hypothesis, or we designed an experiment relative to that hypothesis. We then looked to determine about this hypothesis. We wanted to make a determination about this hypothesis based on the notion of how likely is our data, given that this is true. How likely was it we get 10 red cards in a row, given that this is true? It's highly unlikely. And so we can determine that this hypothesis is most likely false. Okay? Now, how many of you were suspicious after the first card, or second card, third card, fourth card? Fourth card? How about fifth card? Sixth card? It usually hovers around between the fourth and the sixth card. So if we just take 5 red cards in a row, what's the probability I get 5 red cards in a row? Ends up being about 0.03. Just below our traditional threshold value of 0.05. Okay? So I just find that very interesting. This is hopefully a natural way for us to think about hypothesis testing and about probabilities, about our hypotheses. Something similar, what if Kweku comes up and says, I'm a 90% free throw shooter. And you say, well, I want you on my team. So you get him on your team, and he ends up shooting 20 free throws, but he only makes 20% of them. You're going to say, that guy was lying to me. He's not a 90% free throw shooter. And this is exactly what we do when we do hypothesis testing, right? We assume this is true until we look at some data, and the data say, well, the data doesn't line up with this hypothesis. So we reject that first hypothesis and go with something else. Okay? So hopefully that'll give you something to hang your hat on when you're thinking about what does a p-value actually mean. The probability of getting the value at least as extreme that the researchers got or that the data tell us, given that the null hypothesis is true.